Hey everyone, this is Cody, and today I'm going to be doing more testing on the ZWO AM5 harmonic mount. In my last test video, I tested this mount with a heavy payload. I had my big Meade 10-inch Schmidt-Newtonian on here, weighs about 40 pounds, and honestly, I was surprised just how well that worked. So today, I'm going to be doing more testing, and we're going to look at long focal lengths with the AM5. Now, ZWO typically recommends focal lengths of 900 millimeters or less with this mount. Well, today I have my Celestron 9.25-inch EdgeHD Schmidt-Cassegrain with a f7 focal reducer. This has a focal length of 1,645 millimeters or so. So we're going to test it at that focal length. Then I'm going to take this off and we're going to test it at the native f10 focal length of 2,350 millimeters and see how the mount auto guides. So it should be a pretty interesting test today. Now I will say I have been imaging with this mount and the reducer, so I already know the results here and they're really good. Honestly, even with a little bit of wind, I still get excellent auto guiding at the 1,645 millimeter focal length. So I'll show you that in the first night of testing. The second night of testing though, we're gonna see how it does. I've always been a little bit nervous to image at 2350 millimeters just to see how good or bad it is. We're gonna see. So night number 2, we'll take the focal reducer off and shoot at that native focal length, and yeah, we'll see how the ZWO AM5 does today. Now, just like the last test video, I want to minimize as many variables as possible so we can really focus on the mount's auto guiding performance with a long focal length setup. So I went ahead and collimated the Schmidt-Cassegrain last night, so that is good to go. And just like the last video, I'm using the Celestron AVX Tripod. It's a very durable tripod with the ZWO PE200 pure extension. Now you'll notice I don't have any like accessory bars or anything on here. I just wanted to minimize as much weight as possible so we can really focus in on the long focal length here. And then for my imaging train, for the first test, I have the Celestron F7 reducer for the 9.25-inch EdgeHD, a Celestron T adapter, a ZWO camera rotator, this thing is awesome by the way, a ZWO filter drawer, and a ZWO ASI 2600 MC Air, which eliminated the need for the ZWO ASI Air, of course. So it's a pretty simple imaging train. Of course, I have an autofocus here. And yeah, I think I've done a pretty good job eliminating as many variables as possible. And like I mentioned, at 645 millimeters, I've already taken some images and it does a great job. So really, I will show you those results, but I'm really looking forward to the 2350 millimeter test to see how it does there. So I'm going to go ahead and clean off this bird crap off my camera, and then we'll go ahead and get started. One last thing to mention before we get started with the tests is the ASI 2600 MC Air requires a 44 millimeter image circle to fully illuminate the guide camera. The Celestron 9.25-inch EdgeHD only provides a 42 millimeter image circle, whether at f10 or at f7 with the reducer. So my guide stars in this video are probably going to look a little bit weird, maybe a bit comet-like. Just like the previous test when I tested the big heavy Meade Schmidt-Newtonian on this AM5, my guide stars were a little bit weird. It's going to be the same thing here, but I don't foresee that causing any issues. But I just thought it would be something to mention. To save some time in this video, after collimating last night, I did polar align the mount already, so we're good to go. And the target for these tests is going to be the Ring Nebula in the constellation Lyra. That's Messier 57, the Fuzzy Cheerio, one of the first objects I ever looked at through a telescope. It's a beautiful planetary nebula, and to be honest, I'm surprised it's not imaged more frequently. You don't see it pop up a whole lot. So we're going to go for that at 1645 millimeters focal length as well as 2350 millimeters focal length. Now I will say, if I can't get a guide star at 2350 millimeter focal length, I'll just switch targets for that test, but I'm hoping that it works out for both. Alright, I'm out here for test number 1. I'm on target on the Ring Nebula, and I have already autofocus, so saving some time there. So we're going to just go ahead and jump into the guiding calibration. So I'm going to tap on the guider here and hit the button to start refreshing the screen. And yeah, you can see the stars are a little bit weird, so I'm going to adjust them slightly, see if I can get these into better focus. Okay. Yeah, I guess I'll go with that. Probably at these focal lengths, it's a good idea to bin my guider by 2. So I'm going to go to my guide settings. I'm going to go to advanced settings, and I'm going to bend the guide camera by 2 just to improve that signal to noise ratio a little bit here. So I'm going to stop the guider. We're at 2 seconds. We might be able to get away with 1 second actually. There's a lot more stars here than I thought there would be. So that's good news for test number 2 when we do the 2350 millimeter focal length test. Hopefully we'll have plenty of guide stars. So yeah, let's go ahead and calibrate the guider now. Once this is done, I'll be back and we'll start taking some images and see how good the auto guiding performance is with this long focal length setup. Okay, so after a few minutes, you can see we're guiding just fine. 0.41 in dec, 0.67 in RA, and I should have mentioned my polar alignment numbers earlier as well. I was under 10 arc seconds in azimuth and in altitude on my polar alignment, and my guiding performance is looking really good here. So these comet-shaped stars don't really affect the guiding performance, and we saw that when I tested the AM5 with a heavy payload as well. Those comet-shaped stars didn't do a whole lot to affect the guiding performance. So I'm going to go back and we are going to take a 5-minute exposure and see if we still get round stars and how the auto guiding does. Now I'm not going to take 5-minute exposures all night because that would way oversaturate the ring nebula. So I'm going to be shooting 30-second exposures all night, but I just want to see how the mount does with 5 minutes. So let's go ahead and select 300 seconds and start that, and I will be back in 5 minutes or a few seconds for you. Okay, 4 seconds left till this 5-minute exposure is done, and you can see the guiding is excellent. 0.38 in declination, 0.47 in RA. Awesome guiding at 1645 millimeters. It's really impressive actually. Let's see, we'll download the image. And let's see. Wow, yeah, so nebula's very oversaturated. You can see the central white dwarf in there though. That's pretty cool. Let's take a look at our stars. And this is an APS-C size sensor, so I should get really good stars all the way out to the edges. Let's see if how the other side looks. Yeah, these are looking pretty round. Bottom right corner looks good. Little stretching at the top left, but that's not due to the auto guiding, obviously, if the other corners are round. Yeah, it's 1645 millimeters with a 9¼ inch EdgeHD. AM5 is doing just fine. Look at those guide numbers. They look excellent. And as I mentioned, I am in like the heavy mount mode as well. I don't know if that helps or not, but I can't complain about these guiding numbers, so I'm just going to leave it as is. So I'm going to stop this exposure. We're going to take a 30-second image here and see how this preview looks. And once this is done, if everything looks good, we're gonna take the 30-second exposures for the rest of the night. I'll get the guide log and everything, just like the heavy mount or the heavy payload test I did with the AM5. We'll review the image or the subframes, and I'll stack them, and we'll see how the final image turns out. But test 1, it's looking like it's going to be a pretty successful test. So let's download this image here. Guiding's still good. And there is a moderate breeze right now, and it's not affecting anything, so that's a good sign. Alright, let's zoom in, take a look. Yep. Nice round stars. Nice round stars all the way out to the edge. Guiding's looking great. So I think test 1 will be great, and I'm going to go ahead and take these 30-second images the rest of the night, and I'll catch you tomorrow. All right, let's go ahead and check out the data from last night. Here I just have one of the random subs pulled up, and I just want to evaluate the FITS header to see what the actual focal length was. So I was saying 1645 millimeters. I'm just going to go to Process, All Processes, and go to FITS header. And let's see what the actual focal length was here. Did I pass it? Yep, right there. 1669.7565. Okay, so about 1670 millimeters. So we're actually a little bit higher than 1645. So this test was done at 1670 millimeters. And what resolution does that give us? Let's go to the console here. Resolution is right here. 0.464 arc seconds per pixel. Wow, that's pretty high resolution. My seeing conditions definitely are not that good. I deal with a lot of wind and atmospheric conditions, so for test number 2 at the full 2350 millimeter focal length, I should probably do a 2x bin. So we'll see tonight when I run this, but yeah, that is a pretty high res, and so I think it'd be smart to do that. So awesome. Let's get rid of this because I don't need that anymore. I just wanted to see what the focal length and resolution was. And let's blink through the images from last night. Now, most of the time I have to toss about half of my images because the wind gets so bad in the middle of the night. But so far, so good. It's looking all right. Let's see what happens here. Oh, yep, there goes the wind. Starts going crazy on me, and then it gets bright, and I never get to the end of my imaging session. So that is to be expected. Wasted a lot of images there, but you can't control Mother Nature, right? So let's go back to the beginning here, maybe like a quarter of the way down. Just pick some random frames here and check them out. So let's zoom in and see how the auto guiding looks. So round stars here in the center, of course. Let's go ahead and look at the edges. Those look pretty good to me. Let's go up here to this corner. Yeah, still looking good. Top right corner, pretty good. And the bottom right, yeah, looking pretty nice. So auto guiding wise, I think things went pretty well. Let's pick another random image here. Yeah, go over to the corners. Nice round stars. Little bit of stretching here, but the bottom left was round, so I'm going to assume that wasn't an auto guiding issue. It's more of an issue in my optical train. Yep, those are round. Bottom right, those look mostly round too, pretty good. Yeah, so I would say overall, test number 1, pretty successful. I'll go ahead and look at the guide log, but I can pretty much already tell you what it's gonna say. Guide star lost probably, and it'll be obvious that there was a lot of wind that I was dealing with. So I'll get rid of all, like the last half of those images before I stack, of course, and keep those best images. But yeah, looks like test number 1 was pretty successful at that 1670 millimeters of focal length. And tonight, hoping test number 2 goes well at 2350, something I haven't really delved into. So we're gonna see how that goes. Whether it's good or bad, I'll show you those results. So I'm going to head outside, take off my f7 focal reducer, and get the telescope back to the native f10, and we'll see how it does. Okay, so we are out here on night 2 of testing. We are now at the full focal length of 2,350 millimeters, and I've been toying with binning 2 or binning 1 tonight, and binning 2 would give me a resolution of 0.66 arc seconds per pixel. Bin 1 would be 0.33 arc seconds per pixel, and I definitely don't have the seeing conditions to really do that, but I think I'm gonna go bin 1 anyway just to see how the mount performs with it. So for my auto guiding though, I am gonna leave the guide camera set at a bin 2, and that's gonna give me 0.66 arc seconds per pixel on the guide camera. And it's pretty common for you to guide at a lower resolution than what your actual image is at. So, wow, I actually have some stars, so that's a good sign. And yeah, let's go ahead and calibrate. I'm not gonna change the focus there. I think that's okay. If I need to change the focus, I will, but I think we can calibrate on that. So let's go ahead and do that. We'll see how the guiding goes. Crossing my fingers here. So the guiding finished calibrating, and check it out. Numbers look really good so far, so I'm cautiously optimistic. It's settled out nicely. 0.59 arc seconds total error at 2,350 millimeters. That's pretty good. So let's go ahead and take a 5-minute exposure, because why not? So I will go ahead and start that now, and I'll be back in just a split second here. We'll see how the 5-minute exposure turns out. All right, 5 more seconds. Let's see how this turns out. Guiding is still pretty good. Have a moderate breeze going here, so numbers are picking up a little bit. Let's see, bin 1, 5 minutes. It's downloading. Dang, look at that. I mean, obviously I'm not going to shoot 5 minutes on the target, but I just wanted to see, just like test 1, how the guiding was. Round stars, look at that. That's awesome. So at 2,350 millimeters, I'm still getting round stars 5 minutes of guiding at bin 1, 0.33 arc seconds per pixel. That is awesome. So these harmonic mounts really can do a good job on the auto guiding, even at these long focal lengths. And it's not a light telescope either. So I'm gonna go ahead and stop that. And well, we'll just go back down to probably about 30 seconds here, shoot another image, and see how it turns out. Okay, about 6 seconds till this first 30-second exposure ends. And let's see how this one looks. Yeah, I still can't believe how good 5 minutes is. Those stars are very round. Probably even look better than last night, actually. Okay, so here's 30 seconds. Round, 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 all the way to the edge. Yep, round. Round, all the way in the corners. Yeah, this looks awesome. You can see the white dwarf in the middle of the ring nebula there. I'm pretty excited about this. I didn't think it would work that well. I thought I'd get pretty good numbers, but I'm actually surprised by this. So ZWO AM5 auto guiding looks like it's great. So I will go ahead and image the rest of the night, 30 seconds at bin 1. And just like test 1, we'll go ahead and check out the data in the morning. And by the way, these EdgeHD focal reducers are no joke. They got some serious heft to them. So when you take this off the telescope, you're certainly going to be saving yourself a few pounds if you image at the native focal length. So it's kind of a nice little trade-off. Remove the focal reducer, image at the native focal length, but you also save a few pounds, which probably helps your guiding a little bit too. So just thought I'd mention that. Okay, let's check out the raw data from test number 2 at the native focal length of the 9¼ inch EdgeHD. So first thing I want to do is just check what the actual focal length was. So let's go to process, all processes, fits header, and take a look right there. 2,338.58, so roughly 2,340 millimeters or so. About 2,350 overall, awesome. That's pretty long focal length, and these stars look pretty good for that. And then let's look at what resolution that gives us. 0.332 arc seconds per pixel. That's pretty high resolution. I am disappointed in this data though for a couple of reasons. The first reason is my focusing just is not what I want it to be. I think I do have a decent amount of backlash, so with the Schmidt-Cassegrain, I need to kind of dial in my ZWO autofocuser a little bit better, and I think that the autofocus routine would give me much better results if I do that. The other thing is, when I collimated the telescope, I did it with the focal reducer on. I didn't even think about, it didn't cross my mind to do it at the native focal length, but I should have. So I think if I touch up the collimation and get those focuser issues fixed, my images at 2350 millimeter focal length will be much more clear. One other thing I want to do to just this random sub I picked out here was go to Script, Image Analysis, Aberration Inspector, and let's increase these panel sizes to 512. There we go. And if you just look at the stars across the whole image, they're all round. In each corner they're round, on the sides, at top, bottom they're round, in the center. So the EdgeHD does a good job of keeping the stars nice and round all the way to the edge of the field, hence the name of the telescope. And this is just an APS-C size sensor, but it should do a good job with a full frame sensor too. But yeah, overall, stars looking nice and round. So I'm pretty happy with the auto guiding performance here. Let me get rid of this and we'll minimize this image. And let's just blink through the data last night just to see how things went. So this is all the subs we took. Stars looking nice and round still. Maybe went through a couple clouds there. Look at that, nice and round. That is crazy. I did not expect the results to be this good. I was expecting maybe like 1.2 arc, like 0.6, 0.7 arc second error. Whoa. Okay, now we're probably getting lost in the wind. Maybe the meridian flip and the wind kind of caused things to go crazy here. But yeah, the majority of this data looks excellent. I'm really happy with this. And that's just another successful test for the AM5. So it passed with flying colors on the heavy weight test that I did. And now it looks like it's going to pass with flying colors on the long focal length test that we've done here, whether that was 1650 millimeters or 2350 millimeters. I will say once you start getting moderate winds, it's probably going to be game over. Light breeze, it seemed to do okay at 1650. Once you start getting kind of heavier winds, those guiding numbers do seem to jump up pretty quickly, and that just makes sense. At 2350 millimeters focal length and no counterweight, it's a pretty portable setup, but the wind will kind of bite you there. With no wind though, you saw just how good some of these subs were looking in terms of the stars being nice and round. So yeah, I'm pretty happy with this. I'll go ahead and evaluate the guide logs, and then I'll get both of these images processed here in PixInsight and show you the final results. But AM5 looks like it does a great job. Here is the guide log for the first night of testing when I was using the F7 focal reducer. I was shooting 420 light frames, 30-second exposure, bin 1. Now I know I got nowhere near 420 light frames just because of the wind that picked up in the middle of the session, but if I scroll through here, I don't really see anything concerning. Everything's looking pretty good. I'll have a meridian flip eventually in here somewhere. Let's see, scroll. Yep, right there. So we have the meridian flip, replate sols, everything works out from there and continues on. Looks good, and then I start losing the guide star. So that happened, wow, probably about 1/3 of the way through the night. So I could have got a lot more data, but I do deal with a lot of wind, and at these long focal lengths that does tend to start messing things up pretty quickly, and so a lot of this data I had to get rid of because I lost the guide star there. Going over to the second night guide log, so this is test number 2 at F10, 2350 millimeter focal length. You'll see again, everything looks pretty good here. Starting out, does lose the guide star here, might pick it back up, and then it starts imaging again, so it does pick it back up and keeps going. There's a meridian flip here. Guide star lost, so it seems like the meridian flip was probably causing an issue here, combining that with the wind, and yeah, so night kind of starts to go downhill from here. But overall, I think the mount kind of proved itself. It can auto guide at long focal lengths. You might just have to dial in a few things, but really good results overall. So let's go ahead and take a look at the final images. My processing workflow for these images was simple. I did a spectrophotometric color calibration, followed by dynamic background extraction. Then I stretched the planetary nebula and the stars separately and then recombined them, followed by noise exterminator. I didn't want to go overboard with blur exterminator because that can resolve your star trail issues, and I wanted to see the auto guiding results in these final images. That said, I did not adjust intensity transformations whatsoever, no curves, levels, or anything like that at all, and I think that these final images look pretty good. So the AM5 definitely can hold its own at long focal lengths. Now, of course, if you have like a permanent observatory and a big German equatorial mount, I think that's going to work a lot better at long focal lengths, but at least this shows that you can use harmonic mounts at long focal lengths and still get some pretty good results. All right, everyone, well, that wraps up this test of the ZWO AM5 harmonic mount with long focal length telescopes, and whew, that was a lot of recording over multiple days and a lot of data. So if you're still with me, I commend you, but I do think it's important that we get as much data on our mounts, telescopes, and cameras as possible, just so we know what our equipment is capable of, whether you're using it for astrophotography or for scientific research, which I definitely encourage you to pursue if you're a good astrophotographer. So that said, I'll go ahead and post the link to some of the pertinent videos that go along with this subject on how to mount the AM5 to a stable advanced VX tripod, and I'll also post the link to my AM5 heavy weight test if you missed that. So be sure to check the description for those videos, and as always, I hope you have a great day. Thanks so much for watching, and clear skies.